Well, folks, I finally did it. I will be releasing my first small game, Mooselutions, on Steam. It has been a long journey over the course of many years, but I am happy with the result, and I wouldn't have done it any other way. Most of my subscribers are probably used to a certain video format. I make some assertion, and then I proceed to argue for it as a sort of video essay. I enjoy video essays, and I like to put forward my point of view. But I also recognize just how contentious my ideas about software are. They fly in the face of the common tech bro advice telling you to just use tool or engine X. If I say anything that goes against this advice, I know I'll just get a slew of comments telling me why I shouldn't do what I'm doing, and frankly, I find this boring. To avoid repeating the same tired discussions, I'm going to throw out this huge caveat about the path I have taken. I believe that one of the best ways to learn computer science is to make a complete game from scratch in a lower level language like C or C++, and to support that game on multiple platforms so you get a feel for how to do cross-platform software architecture as well. Unfortunately, the culturally dominant portion of the software industry does not do things this way. So while my advice is great if you want to deeply understand how computers and games work, it's terrible advice if you just need to fit in and get a software job right this moment. I have been employed in software, but I don't talk about it much because I don't find it that interesting. There are plenty of channels that do, however, so trust me when I say your demand will be supplied. In this video, I want to take the following angle. Let's pretend you are 18 years old and you want to know if you should go to university for computer science or find some way to support yourself while you make your first video game from scratch instead. What computer science, game design, and art skills might you learn after making that game? How might they compare to a college degree? That's what I want to discuss. At the end of this video, you will have a better understanding of everything involved in making a video game. You will know which elements of computer science you need and which ones you don't. This will help frame your learning process, helping you stick to the fundamentals and avoid many of the computer science education traps out there on the internet. There are many who say it's just not reasonable for a single human being to make a game from scratch. I believe this is clearly false. Although it's much less convenient and you need to build many systems yourself, it's a totally sane thing to do so long as you can constrain yourself to a simple vision for your first game. With that out of the way, let's discuss the game itself and what's in it. Mooselutions is a small 2D Sokoban-style puzzle game with nearly 50 puzzles. You play as a lost lumberjack who is trying to get through a forest full of angry moose who charge at you. It's a systems game that focuses on emergent gameplay. Moose can crash into moose, making them rotate. You can push stacks of bricks in front of moose to hide from them. You can get moose to run onto rail carts so you can push them from behind. There are moose that flip around after they've charged and sort of yo-yo back and forth on the map. Many puzzling situations emerge from this simple set of rules, and the game explores all of the ones I found most interesting. Mooselutions is like a bite-sized Monsters Expedition or Baba Is You kind of game. Because it is a Sokoban, it supports many of the expected features of the genre. You can always undo your last move or reset the entire puzzle with the press of a button. There is a world map that acts like a scorecard, showing you which puzzles you have completed. The game also features 3 distinct seasonal visual themes. It transitions from summer to fall and then winter. Each of these has its own color palette. Mooselutions will be available on Steam for both Windows and macOS. From a programming standpoint, that means the game engine needs to be designed to be cross-platform from the start. And because the game is on Steam, it needs to support Steam achievements. At present, the game has about 7 of them. In order to make the puzzles for the game, I had to build a simple level editor that lets you place various entities into the world. I actually went one step further for this game and integrated the level editor into the game itself, giving me the ability to seamlessly transition from the game to the level editor and back, making it easy to iterate quickly through new puzzle ideas. That's a high-level view of what's in the game. Mooselutions is arguably much more advanced than the kind of game I would recommend people make for their first real project. If you were to make your own game, you wouldn't need to support both Windows and Mac OS out of the gate, and you wouldn't need to launch on Steam either. You could just do Windows and launch it on itch.io, which dramatically reduces the scope. I only chose to support Mac OS because I have a MacBook Pro, and there are certain features of Mac OS that make it easy to take screenshots. Plus, I started on a Mac and just kept going with it. I like having the option to work on my games with my MacBook, but you wouldn't need to do what I did. I just think it's cool. So that's what's in the game. What did I have to learn to make it? I'm going to divide this video into a few sections, starting with the most salient computer science concepts I had to use. That's because you, dear audience, are somewhere between 18 and 34, male, and interested in technology. Next, I will discuss the game design concepts I had to learn, and after that, I'll touch on art concepts. I must tell you that I did not make this game alone. I hired an artist, sound designer, and an illustrator to do the game's Steam capsule. Most of the programming is my own, but I got some help from a contractor who did some very specific fine-tuning in the game's audio mixer. And now, a little history on my game's engine. I learned how to make games by watching Casey Muratori's Handmade Hero. In that video series, Casey makes a complete game from scratch and uses the process as an educational tool to cover as much ground as one can. He builds an audio engine from scratch, CPU rendering from scratch, entity systems, and much, much more. Everything you need to know about programming and games is probably somewhere in Handmade Hero. If only you could sift through it all. I followed the series closely for the first 60 days. That means I literally sat down, watched the videos, wrote the code, tried to get it to compile, saw the results, and fixed the same bugs Casey ran into. My experience was a little different because I started on Mac OS and didn't have any reference materials on how to do a Mac platform layer. I had to do that part myself. After those first 60 episodes, I started to feel like enough of Casey's essence had seeped into my own programming style, like he became my spirit animal. I completed the rite of passage and decided to venture out on my own and make my first game using this newfound pragmatism. I say all of this because if you were to look at the source code for my game, it would not look like a university textbook on game engine programming. It would look like Casey's code, because that's how it started out. As such, the code in my game could be described as straightforward, procedural, or C-like. The college equivalent would be like taking a class on the core concepts in the C programming language and then producing some programs with it. Had you made my game, you would have learned procedural control flow in C, functions, variable types like unsigned and signed integers, floating point numbers, character strings, and structures. Because, like Casey, I manage my game's memory manually, you would have learned about the different memory allocators and how to partition memory using static partitions and memory arenas. You would have most certainly learned about pointers, how to pass them, how to dereference them, what the computer is doing when you use pointers, where the memory for a given pointer variable lives, and all of the standard gotchas that come with using pointers directly. Since my game is cross-platform and needs a way to separate the game's core logic from any specific platform it runs on, like Windows, Mac OS, or Nintendo Switch, it makes use of function pointers. If you could make this game the way I made it, you would have covered pretty much everything from the classic Kernighan and Ritchie textbook, The C Programming Language. Moving one layer up, let's talk about the data structures and algorithms in my game. Most of the heavy lifting in my game is done with simple arrays, but every once in a while, I get fancy. The world map is one such case. It's composed of nodes on a graph, each of which contains pointers to world map nodes above, below, to the right, and to the left. So if you made Mooselutions, you would have learned about graphs and how to use them in a very basic sense. My game uses a really simple recursive world map graph traversal algorithm that dumbly visits all of the nodes in order to draw them. There isn't anything spectacular there, but you would need to know about recursion to do that. I tend to pick up and choose graph structures that are suited to the problem I'm trying to solve. When you make a game, you only need to do what's in the game. Unlike university, you don't get a ton of exposure to all of the different types of graph structures, like binary trees, linked lists, and so on. You'll probably just pick a handful of data structures that you'll know inside and out. It's depth over breadth. Mooselutions uses a queue data structure to process the game's moves. This is why you can press multiple buttons in quick succession and then see the game process the moves as if you had pressed the button slowly. When you press a button, the move gets put into the back of the queue, and after all of the current moves have been processed, the game processes the move you just entered. The queue itself is nothing special. It's backed by an array, but you would need to know how to implement a queue on top of an array to make my game. Okay, on to algorithms. Most of the algorithms in my game involve simple for loops, but every once in a while I will need to pull out something fancy. In order to support Z layers for the 2D sprite rendering, I needed to use a sorting algorithm for the rendered commands. I implemented quicksort, and it seems to do the job quickly enough. My game supports up to 1,000 separate Z layers, which is pretty cool, I suppose. I probably only ever make use of 100 of them at once, but it's neat to know I could do more if needed. And it results in some really cool effects like the layered trees in the game. Notice how the player is always behind the trees. That's my Z layer sorting algorithm. Those three things are the only textbook data structures and algorithms you will find in my game. There are many more ad hoc algorithms I whipped up from scratch to tackle a bunch of different problems that arise naturally. For example, how do you detect if the player has stepped in front of a moose? Another comes to mind, and that's how the game processes the rendering commands on the different platforms. I designed a custom algorithm that minimizes switching between texture atlases, drawing an already sorted array of layered draw commands from back to front. Like most of what's in my game, there was no textbook I could have read to come up with that algorithm. I had to invent it from first principles using what I had. When you make a full game from scratch, there is no hand-holding, no instructor to help you get unstuck, so it's excellent for developing the ability to think for yourself. Oftentimes, you'll come up with a solution that mostly works, and you won't be able to check with others to see if it's the right thing. You just have to keep going and fix it later if there are problems. Now let's go another level higher onto some of the more abstract computer science concepts I had to wrap my head around to do this game. The most important of these is the notion of a state machine. I really had to internalize that concept to support all of the core features in Mooselutions. I don't have time to spell out exactly what a state machine is, but it's basically a way of framing how the game moves from one state to another and so on. In many ways, Mooselutions is just a big state machine. It stores the entire state of the board, the player, the moose, and other moving entities for every move you make. The game's animation system takes a full move's state and animates the transition from that state to the next move's state. The undo system takes the last saved board state and loads it into the game's entity system. If you don't mentally frame the game as a big state machine, the undo features become very difficult to implement. Once you see that the game is just a big state machine, undo is easy to implement. This is perhaps the biggest advantage of a university computer science education. It gives you the breadth to think of things like state machines when you encounter problems like supporting an undo system. If I wasn't exposed to the concept, I might still be scratching my head trying to figure out how to do it. That said, you might get the same exposure through self-study or from talking to a community of puzzle game developers. People making the things you're making tend to run into the same problems. If you read enough books on computer science, I have to imagine you will eventually learn about state machines. They're foundational, going all the way back to Alan Turing and the first digital computers. Next up is math, which sort of dovetails nicely into graphics. Most of the math in Mooselutions never gets more advanced than Isaac Newton's equations of motion, but the game's renderer does indeed require a basic understanding of linear algebra. You need to know what matrices are, how they can be used to represent geometry that gets drawn onto the screen, and how to use matrix operations to translate and rotate geometry. If you do a game engine from scratch, some things are possible without much linear algebra, but certain things like rotating a 2D sprite are basically impossible without that knowledge. I actually think that if your goal is to make 2D games, it's a good idea to try and make a very simple 3D game at some point. That's because it will give you all of the linear algebra tools that make 2D games much simpler by comparison. I took a 2-month break in the middle of working on this game to play around with 3D. I created a simple 3D tile grid and loaded in a few 3D models supporting rotation and translation. I learned so much from that simple exercise, and of course, the knowledge I gained bled into the 2D engine Mooselutions runs on. This is one of those rare moments where I would suggest you don't just work on the project that's right in front of you, but instead work on something different to give you the right foundation. The time investment is worth it. I want to mention multi-threading as well. My game makes very light use of multi-threading to handle some callbacks from Steam and to quickly show a screen while the rest of the game's assets load. You would need to know enough to call some operating system specific multi-threading APIs a few times, and you would need a basic understanding of what not to do when dealing with the parts of your game that use multi-threading. The vast majority of my game's code is not multi-threaded, but where multi-threading is used, it's done well. Moving higher up the stack, we've got all of the operating systems, tools, and third-party APIs you will need to interface with. I lied when I said I made the game from scratch. I really meant to say I made the game from scratch in a pragmatic way, using libraries as sparingly as possible. That, of course, does not remove the need for the game to run on commonplace operating systems like Windows and Mac OS. It does not remove the need to use third-party rendering APIs like DirectX and Metal. I didn't implement Steve achievements all on my own. I linked to Steam's DLLs. I didn't write my own compiler. I used Clang on Mac OS and VS Code on Windows. The game's build system, on both Windows and Mac OS, is totally custom. It uses batch files on Windows and shell scripts on Mac OS. That's 2 separate scripting languages I had to learn. Because the game is multi-platform and uses different renderers on each platform, I needed to learn 2 different shading languages, HLSL for Windows and Metal for Mac OS. There's also the various boilerplate code you will need to hook up to send data over to the GPU and get it to draw your precious geometry. I now know enough DirectX and Metal to draw 2D and 3D geometry using simple shaders. Kinda neat. And then, of course, there are all of the tools you'll need to use. I use RemedyBG as my go-to debugger on Windows and Xcode on Mac OS. I had to do some arcane wrangling to use Xcode solely as a debugger, which meant setting up my project in a non-standard way. Naturally, there is no Ray Wenderlich tutorial to teach you that. You've got to figure it out on your own. I use NeoVim as my text editor regardless of the OS, and I use Git for source control. You would need to know all of those tools to work on my game. Moving ever higher up the stack, we now have the kind of stuff I would classify as necessary bullshit. I don't love Objective-C or object-oriented programming in general, but you're fooling yourself if you don't think you need to know at least a little of it to be effective on macOS or Windows. Yes, you could just write all of your Objective-C interface in C, and I suppose I could have done that, but it's mostly platform code that doesn't get called that much. The core game code is where you need to focus most of your efforts. It's a similar story with the modern C++ features I needed to use. I had to use inheritance and interfaces to interact with some of the DirectX and Steam APIs. I feel dirty, but it needed to be done. Then, at the very top of the stack, are all of the undocumented things you must know, but which have no internal logic or principles guiding them. Things I would classify as trivial bullshit. If you are making an executable on macOS, did you know that your executable needs to be contained inside of a folder with a subfolder named content, which includes another folder named macOS? Did you know that you need to download Xcode and run a program that signs your code? Did you know that you need to run this other program that notarizes your app bundle so other Macs don't treat your game as malware? There's a laundry list of little things like that. Things which get codified into your build process. Things you only ever need to figure out once and just hope you never delete your old repos and lose it. It's my least favorite part of making a game, but it's all stuff you need to know. Okay, tech bros, You can stop watching the video now because I'm going to switch to my favorite topic, game design. I learned a ton about game design by making this game, maybe even more than I learned about programming. Mooselutions is the game where I refined my puzzle design skills and finally started to make puzzles that can entertain an audience for hours at a time instead of mere minutes. Because Mooselutions is a puzzle game, the kind of game design in it is arguably quite different from what one might encounter in many other game genres, board games, or even sports. Good puzzle games have gameplay that could be characterized as discrete, which is to say each level tests knowledge of just one thing. You want to design for a single dominant strategy for every puzzle, one key thing the player must understand to solve the puzzle. This is hard to do because it means you need to select for a set of rules that can express systems which yield a large possibility space. In order to keep the game interesting, there needs to be enough systems in play that every puzzle presents a new strategy which must be employed. You don't want a long series of levels where the player always has to do the same thing. You want a progressive ramp where the player builds better puzzle-solving skills using the tools you give her from the previous puzzles. You want to take the player on a multifaceted odyssey of the mind, exploring elegant truths and emergent phenomena out there in this vast universe of ours. By contrast, many other game genres give you all of the tools at once, and multiple strategies can yield a victory with no preference for one over the other. If you're making a first-person shooter, you can move anywhere on the map, collect any number of weapons, and switch between them freely. There are other people in the world, and you can defeat them using any combination of weapons or strategies. You have to anticipate another player's strategy in order to come up with the right one. You're playing against other players as much as you're playing against the rules of the game itself. An FPS is more continuous by design. It's more about balancing all of the available strategies so one strategy doesn't become the dominant one. If one strategy always wins, the game is no longer interesting. If you want to learn game design, puzzle games are a good genre to work on because they teach you how to construct scenarios that force the player to learn. A single puzzle can teach a lesson about an item, a type of terrain, or some emergent phenomenon that is a consequence of the game's rules. You will learn how to design the game's art to clearly communicate gameplay, and if you fail as a designer, you will know it because the player will get stuck on your puzzles. If you have succeeded, you'll know that too because more people will get to the end of your game. I'm not here to tell you what game genre is the best. Steam players clearly prefer games like Factorio over the very best puzzle games. But even then, I think there's some core elements of a good puzzle game present in Factorio's design. But I'm going to have to save that talk for another video. Mooselutions has 47 puzzles, and each one requires a new strategy. There had to be enough systems and rules to allow for all of this possibility, and I had to spend a great many hours playing the game to find the puzzles I selected. I learned how to discover emergent phenomena and how to curate it so you only see the best of what I found. On to the art. I didn't make most of the game's art. I hired a contractor to do the initial work, and then I tweaked it to create the different seasonal themes. A very small amount of the art is entirely my own, but it's mostly inspired by style guidelines put in place by the game's original artist. It's not to say I didn't learn much about art. I actually learned a great deal. It's just that I didn't learn it by starting from scratch. I stood on the shoulders of my artist. Most importantly, I learned how to construct a color palette that evokes a certain feeling. The game's summer and winter themes are not my creation, but the autumn theme is. I came up with the dark tone, midtone, and highlight. I learned how to hue shift the colors in the game's existing artwork to make it feel like it fits in with the autumn theme. When the player character is in the autumn theme, he still looks like the player. He still has a red shirt, yellow-orange hair, and brown pants, but every single color has been desaturated and hue shifted towards the golden brown orange present in the autumn theme. When you do this hue shifting correctly, it makes it look like the player belongs in his surroundings. When you do it poorly, the player sticks out like a sore thumb. Once you have everything looking like it fits in the scene, you can start cutting colors from the palette. Cut as many colors as you can, but not so many that the scene loses its distinctive character. It's a lot of trial and error. I'm still figuring this out. If I were to judge my autumn theme, I would say it hits the mood correctly, but probably needs to use some of the greens and purples in patches here and there so it's not so one-sided. I also created a few of the game's animations myself. The idle moose breathing animation is mine. I also did the player's breathing animation, which is far more subtle. I'm not sure how I feel about the result, but I definitely learned a great deal about keyframes. Although it seems easy, the pixel art style is actually harder to pull off than HD art. I think I'll try an HD art style for my next game just to change it up and see how it compares. Let's wrap up this video. I am going to launch Mooselutions on Steam. I will need to undergo a minimally invasive heart valve surgery before I release it, but rest assured my risk of mortality is very low. The nurse says it's 0.2%, and I'm guessing most of that is from people who don't tolerate anesthesia well. Mooselutions comes out on January 29th, 2024. I'm going to spend the remaining time polishing up the experience and responding to your player feedback. Please take this moment to wishlist Mooselutions on Steam. The link is at the top of the description. At the start of this video, I told you to pretend that you are an 18-year-old person with the choice to go to college or spend the same time making your own game. Given what I learned, what would you do? I am 40 years old. I went to college back in the early 2000s at the University of Colorado in Boulder. I majored in philosophy and minored in computer science. For me, the value in the degree comes from getting exposed to a wide variety of topics and perspectives. The people I met and the conversations I had. I would consider myself more well-rounded because I went. The downside was the price and the opportunity cost, and in that regard I am privileged because my college was paid for. Would I make the same decision today if I had to pay for it myself? Probably not. It's more expensive than when I went, and judging the curriculum currently available, I'm not totally sold on the value of it. But I've gone on long enough. I'll discuss that topic in the next video. Thanks for watching, and if you liked the video, please hit the like button and subscribe. Here's one of my favorite quotes about learning from science fiction author Frank Herbert. Thinking you knew something is a sure way to blind yourself. It was not growing up that slowly applied the brakes to learning, but an accumulation of things I know.